Back in this video, I'll be solving little problem 338, counting bits. So given an integer n, return array answer of length 10 plus 1, such as for each I from 0 till n, answer of I is the number of ones in the binary representation of phi. Okay, and log n is easy. Can we do it linear and a single pass? Okay, we'll do it. Linear and single pass, and this I wouldn't say is easy because you just have to know and play with the numbers. So let's see what we got. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's keep it on like this. So this is 0, this is 1, this is 1, 0, this is 1, 1, 1, 0, 0. And we already here can see some repetition. So we had 0 and 1. And now we just add this one. And we just append 0 first and then 1. Then for this one, we have new one. And we just start again from scratch with this one. So that's 1 plus this. And it's 1 plus again this. Then it's... I don't even have to look at the number, it's just 1, 1, 1, 0, and at the end 1, 1, 1. So now this part is the second two digits are repeated from up there, and essentially that's it. We go on like that. So what this tells us. So we need to check if we are if we have, so we'll start with 0. 0 is 0 for sure, and then each time we have maybe we also start with 1. So 1 is so how do we, so from here do we have 0 and then we have 1. That's the beginning. Now we have to, so if we have potential of 2, and the first that we were looking was 2, so 2 to the 1. If we have it, then our new offset is that potential. So this is actual net potential, but the value. So 2. So here we have 1 plus previous minus 2. Let's call it like this. This one is again 3 is again 1 plus previous minus 2, and so on. So here we'll have 1, but when it's equal 4, we'll switch up here and have offset 4 and so on. So that's generally approach here. So we have answer, and since we go from 0 till n included, we will have values 0 times n plus 1 and offset yeah, let's make it offset 1. So for I in range n, but from 1 and plus 1, so what do we check? If offset, if I is equal offset times 2, then offset is offset times 2, and if not, I use answer of I is 1 plus answer of I minus offset. So that's the idea, and I just return answer. So I think this is it. Seems good, and it's working. So let's follow through this one more time. We initialize with a 0. We say firstly offset is 1, so that's 2 to the 0. And for I in range, that's why we start from 1. It's always new most significant bit plus offset from the previous, and offset is currently 1. So we do that, and answer of 1 is 1 because this is 0. Then we go to the 2. I is equal to offset times 2. Then we need to double the offset. So now offset is 2, and for this one we have 1 minus 1 minus 2, so 1 plus 0, that's again 1. Then for 3 we have again 1 plus this one, so that's 2. And when we come at 4, for 4 we again are offset times 2, so we increase our offset to 4, and now we have most significant bit is again new one, so we have 1 here, and we go minus 4, so we 1 plus 0, 1 plus 1, and this part repeats. And that's essentially it. Maybe write it down, but when you write it down, I think you're gonna get it. Nothing too complicated, but if you know it, you know it. If you don't, you don't. So yeah. Okay, time complexity, space complexity. So O of n for answer here. And time complexity again of n, because we go through all values from 0 to n and do this. So yeah, okay, if you have any questions, leave them in comments. I appreciate you following this one, and see you in the next one.